Where the stars are bright, the science is gentle, and the only thing faster than the speed of light is how quickly we hope you'll drift off to sleep. Tonight we're taking a slow, dreamy voyage through our cosmic neighbourhood, a quiet meander past 8 very different worlds, all orbiting the same faithful star. From the blistering cliffs of Mercury to the icy winds of Neptune, each planet has its own personality, quirks, and charm. And don't worry, you won't need a spacesuit, just a comfy pillow and perhaps a cup of tea. Now, I should offer a small, polite warning. While I do hope this video helps lull you into a lovely sleep, there's always the risk it might be too interesting. If you find yourself lying awake wondering how Uranus ended up sideways or why Jupiter is basically a giant storm in a tuxedo, well, at least you'll be learning something on your way to dreamland. Before we begin, if you enjoy these gentle, sleepy journeys through science, it would mean a lot if you could tap the like button and perhaps subscribe so you don't miss future trips through time, space, and everything in between. It's free and helps this little starship keep floating. Also, if you're still awake, which is entirely optional, I'd love to know where you're listening from and what time it is for you right now. Are you curled up in bed at 10 o'clock at night in London, listening from a cosy cabin in the woods at midnight? Or maybe you're halfway across the world welcoming the sunrise in silence. Whatever your place and hour, you are welcome here. There's no rush, no test at the end, just a slow, soothing wander through the universe, where you can drift and doze at your own pace. Now, close your eyes if you like, breathe deeply, and let's begin our journey. 1 star, 8 curious worlds, and you floating gently in between. Let us begin where everything does, with the sun, a blinding sphere of fire 400 times farther than the moon and 400 times larger, which is why the two appear the same size in our sky. But make no mistake, the sun is no modest ball of light. It is a gargantuan furnace, a churning engine of fusion over 1 million times the volume of Earth, and it is the gravitational anchor that holds our entire solar system together like a careful parent with 8 wildly different children. The sun is a star, not particularly large as stars go, but not especially small either. It's what astronomers call a yellow dwarf, which feels a bit unfair considering it's over 860,000 miles across. Inside it, every second, hydrogen atoms are being pressed together under unimaginable pressure to form helium. This process, nuclear fusion, releases energy that travels from the sun's core to its surface and then out into space as sunlight warmth and a gentle sense of please wear sunscreen. It takes that light, on average, about 8 minutes to reach us here on Earth, which means when you glance at a sunrise, you're looking 8 minutes into the past, a warm ghost of a moment just missed. The surface of the sun is not solid, it's a boiling sea of plasma, where temperatures hover around 10,000 degrees Fahrenheit. But deep in the core, it's much hotter, over 27 million degrees. That's hotter than anything you've ever imagined, unless you've tried sitting in a car in July with the windows rolled up. The sun rotates too, although not like a rigid body. Because it's made of gas and plasma, the equator spins faster than the poles. A full rotation takes about 25 days at the equator and around 35 days nearer the poles. It's like a spinning pancake where the syrup moves faster than the edges, a messy, glorious magnetic pancake of fire. Speaking of magnetic fields, the sun's magnetic activity is dramatic. It creates dark sunspots, cooler regions caused by tangled magnetic fields, and solar flares, which are massive eruptions of energy that can shoot charged particles toward Earth. Sometimes these solar storms can mess with satellites or even cause auroras, those dancing lights you might see near the poles. The sun is always bubbling, burping, and occasionally throwing tantrums that echo across the solar system. And yet, despite all this power, we owe our lives to its quiet consistency. The sun has been shining steadily for about 4.5 billion years, and it's expected to continue for another 5 billion or so before transforming into something entirely different. Not a supernova. Our sun isn't big enough for that kind of drama, but eventually it will swell into a red giant, shedding its outer layers in a sort of slow, graceful farewell. What's left behind will be a white dwarf, a tiny, dense remnant no bigger than Earth, but with the mass of the sun slowly fading into cosmic memory. But that's a long, long time from now. Tonight, the sun remains our star, glowing gently on the far side of the planet, casting moonlight on your window, powering plants, warming oceans, and gently steering the orbits of every object that belongs to its family. It's hard to overstate just how dominant the sun is. It contains over 99% of all the mass in the solar system. That includes all the planets, all the moons, every asteroid, comet, and wayward space probe. All of it could fit inside the sun with room to spare. Even mighty Jupiter, which could swallow Earth over 1,000 times, is dwarfed by the sun's sheer scale. And yet, for all its size, we rarely stop to appreciate it. It rises and sets, or rather, we spin, and its familiar presence becomes background noise. But try to imagine a sky without it. No seasons, no weather, no life, just cold, dark silence. There's something oddly comforting in its constancy. The same sun that warmed the backs of fervent lizards 100 million years ago is the one that glints off skyscrapers today. The photons that hit your skin this morning were born in the core of the sun thousands of years ago, slowly crawling their way to the surface before racing across space at the speed of light. Even time itself bends to the sun's will. Our calendars, our days, our biological rhythms, they all revolve, quite literally, around this star. We wake with it, we rest in its absence, and from time to time we gather to watch it disappear behind the moon, in eclipses that remind us just how small we are in the grand ballet of space. In ancient times, people worshipped the sun. They built temples aligned with its rising and told stories of gods who rode golden chariots across the sky. Today we understand the science behind it, but perhaps that sense of awe has not entirely left us. Nor should it. Because while the sun is just one of billions of stars in the Milky Way, to us, it is home. So as you lie there, drifting further into rest, know that above you, and all around you, the light of the sun keeps travelling, falling upon frozen moons, glowing through Saturn's rings, illuminating distant comets, and warming our little planet just enough for water to stay wet and dreams to grow. The sun will still be there in the morning, still burning, still shining, still anchoring every orbit in its gentle, fiery embrace. You don't need to understand every detail to feel its presence. Just breathe in the warmth, even now, and let it lull you into calm. You're part of this system, a stargazer, a sleeper, a thinker under the sky. And that sky, though vast and ancient, is lit by a star that knows your name. Now that we have met the sun, the grand conductor of our celestial symphony, let's drift gently to the first planet in line, Mercury. If the solar system were a racetrack, Mercury would be the sprinter who insists on doing laps at breakneck speed, always chasing the sun and never quite cooling down, is the closest planet to the sun, orbiting at an average distance of about 36 million miles. That's less than half the distance between the sun and Earth. A cosy neighbour, if you consider blistering radiation and searing silence cosy. Mercury is the smallest of the 8 major planets. It's only slightly larger than Earth's moon. In fact, if you ever saw them side by side, you might mistake one for the other. But Mercury isn't a moon, and it isn't especially friendly either. It's more like a battered old warrior, scarred, scorched, and silent. The surface of Mercury is covered in craters, cliffs, and ancient lava plains. It bears the marks of billions of years of cosmic collisions like the moon, but even more extreme. There's no atmosphere to soften a meteor's impact, so when something hits Mercury, it hits hard and leaves a lasting impression. Imagine a world where time doesn't wash things away, where ancient scars remain visible for eons. Mercury is a planet that remembers everything. Now, being close to the sun, you might expect Mercury to be the hottest planet. But oddly, it's not. That honour goes to Venus, which we'll visit later. Mercury may get incredibly hot, Temperatures can soar to over 800 degrees Fahrenheit during the day, but it also gets unimaginably cold at night. Without a thick atmosphere to trap heat, the temperature can plummet to minus 300 degrees. That's a swing of over 1000 degrees Fahrenheit between day and night. You would need quite a flexible wardrobe to live there. And speaking of day and night, time on Mercury is wonderfully strange. A single day on Mercury from one sunrise to the next takes about 176 Earth days. That means if you stood on the surface and waited for the sun to rise, move across the skies and set again, you'd be there for almost 6 Earth months. Oddly enough, a year on Mercury, a full orbit around the sun, only takes 88 Earth days. Yes, you heard that right. The year is shorter than the day. This strange situation is thanks to what's called a spin-orbit resonance. Mercury rotates very slowly. It turns on its axis just 1.5 times for every trip it makes around the sun. It's like a planet that can't decide whether to be fast or slow, so it settles for doing both at once. If Mercury were a person, it might be the one who sprints to the grocery store and then spends 3 hours slowly wandering the aisles. And if you were standing on Mercury's surface, assuming you could survive the temperature, radiation, and lack of oxygen, you'd see some very peculiar sights. During certain times, the sun would appear to rise, then briefly set again, and then rise once more before continuing its path across the sky. It's all due to Mercury's highly elliptical orbit and that odd spin. The sun plays hide and seek, and the sky never behaves quite the way you'd expect. There's no weather on Mercury, no clouds, no rain, no wind to whistle through the craters, just silence. The only things that move are the shadows, which crawl slowly across the landscape as the distant sun makes its strange journey overhead. Despite this stillness, Mercury isn't entirely dead. Beneath its solid surface lies a surprisingly large metallic core. In fact, scientists believe the core makes up about 85% of the planet's radius, much more than Earth's. This large core generates a weak magnetic field, which was a surprising discovery. It's only about 1% as strong as Earth's, but its mere presence was enough to puzzle researchers for years. And there's more mystery. Some regions near Mercury's poles are permanently shadowed, hidden from the sun's harsh rays by deep crater walls. In these frozen shadows, scientists have detected what they believe is water ice. Yes, ice. On the nearest planet to the sun. It's a wonderful contradiction. A hot, dry planet with pockets of eternal frost. Humanity has sent spacecraft to Mercury, though not many. The first was Mariner 10 in the 1970s, which managed to photograph less than half the planet. More recently, NASA's Messenger mission spent 4 years orbiting Mercury, giving us our most detailed view yet. Messenger revealed incredible things, strange hollows in the surface, surprising chemical compositions, and those hints of polar ice. And there's more to come. The European Space Agency's Bepi Colombo mission, named after Italian scientist Giuseppe Colombo, who helped explain Mercury's spin-orbit resonance, is currently on its way to the planet. It's a complex 2-part spacecraft expected to arrive in the early 2030s, ready to deepen our understanding of this elusive world. Mercury's name comes from Roman mythology. Mercury, the messenger of the gods. Fitting in a way for a planet that races around the sun, always moving quickly, always silent. It's the sprinter who whispers rather than shouts, the ancient traveller who never stays in one place for long. And despite its closeness to the sun, Mercury is very difficult to observe from Earth. It never strays far from the sun's glow in our sky. It appears just before sunrise or just after sunset, hugging the horizon and in brief, golden flashes. For centuries, many people never saw it at all, and even today, it's easy to miss unless you know exactly where to look. But now you've been there, if only in your imagination. You've wandered the cratered plains, watched the double sunrise, and shivered in the silent shadows. Mercury is not a planet we dream of visiting, not a likely home for future humans, but it is a world with its own quiet dignity, fast, strange, and enduring. So let us drift onward, warmed slightly by the glow of Mercury's sun, and carry with us the memory of a planet that spins slowly, orbits quickly, and never stops whispering secrets into the cosmic wind. Now we come to Venus, Earth's sister, they say. Similar in size, mass, and composition, but make no mistake, this sister has a temper. Imagine Earth after a particularly bad day, draped in thick clouds, seething under crushing pressure, and hot enough to melt lead. That's Venus, beautiful from afar, absolutely inhospitable up close. Like a gorgeous kikali that turns out to be made entirely of lava and rage. Venus is the second planet from the Sun and is just slightly smaller than Earth. If you put the two side by side, their resemblance in shape and density would be uncanny. But that's where the similarities end. While Earth is wrapped in a breathable atmosphere and covered in oceans, Venus is blanketed in thick clouds of sulfuric acid, with a dense atmosphere composed mainly of carbon dioxide. It's like Earth decided to wrap itself in a toxic sauna and crank up the heat to unbearable levels. Speaking of heat, Venus is the hottest planet in the solar system. Yes, even hotter than Mercury, which is closer to the Sun. That's because Venus's atmosphere creates a runaway greenhouse effect, trapping heat so efficiently that surface temperatures can soar above 860 degrees Fahrenheit. That's hot enough to melt zinc, tin, and even lead. If you were standing on the surface of Venus, which is not advised, you'd be simultaneously cooked, crushed, and dissolved. Not the most welcoming travel destination. The atmospheric pressure on Venus is another nightmare entirely. It's about 90 times greater than the pressure on Earth at sea level, roughly equivalent to the pressure you'd feel nearly 3,000 feet under the ocean. So if the heat doesn't get you, the pressure will. Venus is like a slow-cooking pressure cooker, simmering for billions of years, and then there's the atmosphere itself. Those thick yellowish clouds are filled with sulfuric acid droplets. The skies above Venus are endlessly stormy, filled with fast-moving winds that whip around the planet at speeds of over 200 miles per hour. But down on the surface, the air moves sluggishly, heavy and still, as if it's too tired to bother after pressing down with so much weight. Venus also spins in a very unusual way. First, it rotates extremely slowly. One rotation takes about 243 Earth days. That means a single day on Venus is longer than its year, which lasts around 225 Earth days. Even more bizarrely, Venus spins in the opposite direction of most planets. So if you were watching the Sun from the surface, again, from inside your reinforced, probably imaginary survival capsule, the Sun would rise in the west and set in the east. A slow backwards dance under an acidic sky. Scientists believe that Venus may not have always been this way. Billions of years ago, Venus might have had oceans, or at least a more temperate climate. But something changed, perhaps volcanic activity, or a slow accumulation of greenhouse gases, and the planet's climate spiraled into its current inferno state. Studying Venus is more than just a planetary curiosity. It offers a dramatic example of what can happen when a planet's climate goes unchecked. Despite these extreme conditions, Venus has long fascinated humanity. It is the third brightest object in the sky after the Sun and the Moon, and it often appears as the morning star or evening star. For ancient civilizations, Venus was both a symbol of beauty and mystery. Its appearances and disappearances in the sky mark calendars, guided mythologies, and inspired poetry. Modern scientists too have been captivated. The Soviet Union's Venera program was the first to land spacecraft on Venus, starting in the 1960s and continuing through the early 1980s. Venera landers provided the first images from the surface, haunting photographs of cracked, dry terrain under a dense mustard yellow sky. These missions didn't last long. The intense heat and pressure quickly destroyed them, sometimes in less than an hour. But in that short time, they gave us our first look at this distant world's harsh beauty. Later missions from NASA and the European Space Agency have mapped Venus using radar, since optical imaging is nearly impossible through its thick clouds. These radar maps revealed vast plains, highland regions and enormous volcanoes, some of the largest in the solar system. There's even evidence that Venus might still be geologically active. Tremors, lava flows, and shifting surface features suggest that it may still be rumbling deep beneath its toxic skies. One particularly fascinating feature of Venus is its tesserae, highly deformed regions of crust that look like wrinkled, crumpled terrain. These areas are unlike anything found on Earth or any other planet and hint at complex tectonic processes that are still not fully understood. Venus doesn't have plate tectonics like Earth does, but it does seem to stretch, fold and reshape itself in strange and mysterious ways. There's also speculation about the possibility of life, not on the surface, which is utterly inhospitable, but high in the cloud layers. About 30 miles above the surface, temperatures and pressures become more Earth-like. In this region, some scientists have wondered if microbial life could potentially survive, floating among the acidic clouds. It's a long shot, but a tantalizing one. In 2020, a team of researchers detected a gas called phosphine in Venus's atmosphere, a compound that on Earth is often associated with biological process. The discovery sparked enormous interest, though later observations cast some doubt on the findings. Still, the idea has reignited plans for future missions. NASA and ESA are both planning to return to Venus in the coming decades with missions like Veritas, Da Vinci Plus and Envision. These orbiters and probes will study the planet's atmosphere, surface, and possible signs of past or present geologic activity. The hope is to unravel the history of Venus, to learn how it became so different from Earth despite starting with so many similarities. Venus is a planet of paradoxes, a twin that isn't, a world of searing heat and crushing air, yet named after the Roman goddess of love and beauty. It is both mesmerizing and terrifying, inviting and completely hostile. And yet, we keep looking up at that bright morning star, wondering what it hides behind its golden veil. So next time you see Venus glowing low in the sky, remember what lies beneath those pretty clouds. A slow-turning world of fire and storms, where time moves oddly and the sun sets in reverse. A warning, perhaps, or a mystery waiting to be solved. Either way, it shines on, beckoning through the silence of space, distant and dazzling. Now we arrive at Earth, our blue marble, our floating home, our only known oasis in the great dark sea of space. It's easy to overlook Earth in a journey through the solar system. After all, we see it every day. But when you step back and view it from a distance, from space, it becomes something altogether extraordinary. Earth is the only planet we know of that has liquid water on its surface, an oxygen-rich atmosphere, and a biosphere bursting with life. As far as we can tell, it's the only planet that has ever written a poem, baked a cake, or wondered what stars are made of. Earth is the third planet from the Sun, orbiting at an average distance of about 93 million miles, just the right spot in what scientists call the habitable zone, or more whimsically, the Goldilocks zone. Not too hot, not too cold, just right for water to remain liquid, for clouds to form, and for oceans to slosh endlessly across the surface. Our planet is about 7,900 miles in diameter and is made up of layers, a solid inner core, a liquid outer core, a thick mantle, and a relatively thin crust, which is where we live. But even that crust is constantly moving. Earth's surface is broken into tectonic plates that shift, collide, and drift over time. These movements create mountains, earthquakes, and volcanoes, the dynamic reshaping of a planet that refuses to sit still. Unlike our rocky neighbours Mercury and Venus, Earth has a remarkably active climate system. The atmosphere, a mix of nitrogen, oxygen, argon, carbon dioxide and other gases, protects life from harmful radiation, traps heat to maintain stable temperatures, and allows water to cycle through rain, snow, rivers and oceans. Weather may be inconvenient at times, especially when you forget your umbrella, but it's a vital part of Earth's life support system. And speaking of water, Earth is a watery wonderland. About 70% of the surface is covered by oceans, seas, lakes, and rivers. Water flows, freezes, evaporates, and falls in an elegant continuous loop known as the hydrologic cycle. This abundance of water is part of what makes Earth so unique. Water acts as a thermal buffer, moderating climate and sustaining the web of life. But Earth's most defining feature, the thing that makes it unlike any other known planet, is, of course, life. From microscopic bacteria in thermal vents to towering redwoods and migratory whales, Earth teems with the organisms that have adapted to every conceivable niche. There are creatures that glow in the dark, plants that eat insects, and fungi that can survive in radiation zones. Life here is resilient, bizarre, and endlessly creative, and among all those organisms is one particular species, humans, who figured out how to build telescopes, launch rockets, and ask big questions. Questions like, where did we come from, and are we alone? And is there any chocolate left in the cupboard? Are questions that are equal parts profound and snack-related. Earth's moon plays a surprisingly important role in all of this. Our moon is relatively large compared to our planet, about 1/4 of Earth's diameter, and it helps stabilize the tilt of our planet's axis. That tilt is responsible for our seasons. Without the moon, Earth's tilt might wobble wildly over time, making climate far less predictable and possibly less hospitable to life. The moon also controls the tides, pulling at Earth's oceans with its gravity in a rhythm that has shaped life for billions of years. And Earth spins. It completes one full rotation on its axis every 24 hours, giving us day and night. At the same time, it orbits the Sun once every 365 1/4 days, hence the need for leap years, which kindly tidy up that spare quarter day every 4 years. The journey around the Sun isn't a perfect circle. Earth's orbit is slightly elliptical, meaning we're a little closer to the Sun in January and a bit farther away in July. But don't worry, the seasons are caused more by the tilt of Earth's axis than by our distance from the Sun. Summer happens when your hemisphere is tilted toward the Sun, and winter when it tilts away, regardless of how far Earth is from the centre of our system. Now, let's not pretend the Earth is perfect. It's a little chaotic. Hurricanes, earthquakes, and volcanic eruptions remind us that our planet is both beautiful and volatile. And human activity, especially over the past 2 centuries, has introduced new challenges like climate change, pollution, and the loss of biodiversity. But still, even in the face of these problems, Earth continues to be astonishingly generous. There's also something poetic about Earth's invisibility from most of the solar system. From Mercury, Venus, and Mars, Earth can appear as a bright star in the night sky, but it reveals nothing of its oceans, forests, or laughter-filled cities. From Jupiter and beyond, it fades to a pale dot. When Voyager 1 looked back and captured that famous image, a tiny blue speck suspended in a sunbeam, Carl Sagan called it the pale blue dot, reminding us just how fragile and precious our world really is. It's humbling to realize that everything you've ever known, every person you've ever loved, every meal you've ever eaten, all of it happened on this little speck spinning in the void. Earth is not just a planet, it's our only known home. A world where atoms gathered into molecules, and molecules became cells, and somehow, out of all that, came music and stories and dreams. From space, Earth has no borders, no politics, no noise, just swirling clouds, deep blue oceans, and brown and green land masses drifting across its surface. Astronauts often speak of a profound shift when they see Earth from orbit, a realization that our differences shrink when viewed from above, and that we are all passengers on the same fragile vessel, sailing through the cosmos. So as you lie there, listening, breathing gently, let yourself feel the pull of Earth, not just its gravity, but its presence. You're made of the same elements as this planet: carbon, oxygen, nitrogen, and iron. You're part of its story, woven into its ecosystems, touched by its sunlight and cradled by its magnetic field. And as the Earth spins beneath the stars quietly, faithfully, it continues to shelter us, nourish us, and whisper stories of its ancient oceans and drifting continents. It is, in every sense, our mother world. Rest easy, knowing that beneath you is a living planet full of wonder, and that above you the stars still shine. Distant, yes, but never out of reach for a curious mind. Now we leave the warm familiarity of Earth and set our course for a world that has fascinated dreamers, scientists and storytellers for generations: Mars. Mars is the fourth planet from the Sun, orbiting just beyond Earth in the cold, rust-coloured reaches of the solar system. It's often called the Red Planet, and for good reason. Its surface is coated in iron oxide, essentially rust, which gives the entire planet a reddish hue. From afar it looks like a faded ember, glowing quietly in the dark. But up close, Mars is a world of canyons, craters, frozen deserts, and long-lost rivers, a planet that once may have looked a little like home. Mars is about half the size of Earth, with a diameter of roughly 4,200 miles. Its gravity is only about 38% of Earth's, meaning if you weigh 100 pounds on Earth, you'd weigh just 38 pounds on Mars. Your footsteps would be lighter, your jumps higher, and your grocery bag significantly less troublesome. The surface of Mars is cold and dry. Average temperatures hover around -80 degrees Fahrenheit, and at the poles it can dip as low as -200. But unlike Mercury or the Moon, Mars has an atmosphere, thin yes, but present. It's composed mostly of carbon dioxide, with trace amounts of nitrogen and argon. There's almost no oxygen, which makes taking a deep breath on Mars a very bad idea. You'd need a sturdy spacesuit and a reliable supply of air. But the sky above you would be a soft orange, and the sun would rise and set like a dim golden ember. One of the most striking features of Mars is its landscape. It's a world of extremes. There's Olympus Mons, the tallest volcano in the solar system. It rises about 75,000 feet high. That's nearly 3 times taller than Mount Everest. And then there's Valle Marineris, a canyon system so vast it stretches over 2,500 miles across the planet, about as wide as the continental United States. Some parts of this canyon reach depths of over 4 miles. It's as if the entire surface cracked open, revealing the ancient bones of a restless world. But perhaps the most captivating part of Mars isn't what it is today. It's what it might have been. There's evidence that liquid water once flowed across the Martian surface. Ancient riverbeds, deltas, and lake beds hint at a time when Mars had a thicker atmosphere and a more temperate climate. Some scientists even believe that oceans may have once covered large portions of the northern hemisphere. Today, most of Mars's water is locked away in ice caps at the poles or hidden as frozen reserves beneath the surface. But during certain seasons, dark streaks appear on some Martian slopes, features known as recurring slope lineae, which may be linked to salty water brines seeping up from underground. It's not exactly beach weather, but it's enough to keep scientists wondering, could something microbial, hardy, microscopic still be alive beneath the red dust? Mars has 2 small moons, Phobos and Deimos. They're irregularly shaped, like captured asteroids, and look more like large potatoes than the round moons we're used to. Phobos, the larger of the 2, orbits Mars so quickly that it rises and sets twice each Martian day. Eventually it's expected to crash into Mars or break apart into a ring, but not for another 30 to 50 million years, so there's no need to rush. A day on Mars, known as a sol, is remarkably close to a day on Earth. It lasts about 24 hours and 39 minutes. A Martian year, however, is longer. It takes roughly 687 Earth days for Mars to complete one orbit around the Sun. That means if you move to Mars, your birthdays would be less frequent, but your days would feel pleasantly familiar. Mars also experiences seasons just like Earth, because its axis is tilted by about 25 degrees. There's a Martian spring, summer, autumn and winter, though they last longer due to the extended year. In winter, carbon dioxide from the atmosphere freezes and falls as dry ice snow at the poles. Imagine snowflakes made of solid gas, a delicate dusting from an alien sky. The idea of living on Mars has captured human imagination for centuries. Early observers thought they saw canals, perhaps built by intelligent Martians. These turned out to be optical illusions, but the dream endured. Today, Mars is a prime candidate for future exploration and perhaps one day colonization. Over the past few decades, we've sent a fleet of robotic explorers to Mars. Rovers like Spirit, Opportunity, Curiosity, and Perseverance have trundled across its surface, taking photos, drilling into rocks, and searching for signs of ancient life. The Ingenuity helicopter, a small solar-powered flyer, became the first aircraft to fly on another planet, hopping through the thin air of Mars like a dragonfly on vacation. These missions have taught us an incredible amount. We've discovered complex organic molecules in the soil, methane bursts in the atmosphere, and evidence of ancient hydrothermal systems. We've even begun experimenting with converting carbon dioxide from the Martian air into oxygen, a small but vital step toward possible human survival. Why does Mars matter so much to us? Maybe because it's close enough to reach, harsh but not impossible, familiar yet alien. It's the next great frontier, a mirror to our past, and a window into our future. It reminds us that planets change. They cool, they dry, they evolve, and perhaps they can be revived. From a sleepy vantage point here on Earth, Mars is just a reddish star in the night sky. But up close, it's a dusty time capsule, a world with valleys that once echoed with rushing water, volcanoes that pierce the sky, and a potential for life still hidden beneath the surface. So imagine yourself there, standing on a windswept plain, the sky dim and pink, the sun low on the horizon. The cold air barely stirs and your boots leave faint prints in the rust-coloured dust. You are a visitor in a silent world, older than any story waiting patiently to tell its own. And maybe, just maybe, it's been waiting for you. Now we begin to drift away from the inner rocky planets, crossing the invisible boundary that separates the familiar from the colossal. Beyond the asteroid belt, a new class of world awaits, vast, stormy, and gaseous. Our next stop is Jupiter, the fifth planet from the Sun, and the undisputed giant of our solar system. If the planets were a family, Jupiter would be the oldest sibling who never stops growing and insists on bringing the weather wherever they go. It's the largest of all the planets, so massive in fact that it contains more than twice the mass of all the other planets combined. You could fit over 1,000 Earths inside Jupiter and still have room to spare for snacks. But despite its overwhelming size, Jupiter isn't solid. It's a gas giant, composed mostly of hydrogen and helium, the same elements that make up stars. If you tried to land on Jupiter, you wouldn't find a surface to stand on. You'd simply descend into deeper and denser layers of gas, passing through clouds, storms, and pressure so intense it would crush even the most robust spacecraft long before you reached anything remotely solid. Still, Jupiter is anything but boring. Its cloud tops are a swirling banded spectacle, creamy whites, burnt oranges, deep browns, shaped by powerful jet streams that whip around the planet at hundreds of miles per hour. These bands are made of different types of clouds, rising and sinking at different altitudes. It's like watching a never-ending, planetary-sized marble painting in motion. And then there's the storm, the Great Red Spot, a colossal hurricane larger than Earth, has been churning in Jupiter's southern hemisphere for at least 350 years, possibly much longer. It spins counterclockwise, with winds reaching speeds of over 400 miles per hour. Imagine a storm so argent old that entire generations have come and gone under its watchful swirl. Jupiter doesn't do anything halfway. One full rotation on Jupiter takes just under 10 hours, making it the fastest spinning planet in the solar system. Despite its size, its days are incredibly short. This rapid spin gives the planet its slightly flattened appearance, bulging at the equator and squashed at the poles, like a ball of dough spun too quickly. And yet Jupiter's influence extends far beyond its atmosphere. Its magnetic field is the strongest of any planet, about 20,000 times stronger than Earth's. This enormous field traps charged particles in radiation belts that would fry unprotected spacecraft. It's like a giant electromagnetic lighthouse, sweeping waves of energy through space. Jupiter also has a faint ring system discovered in 1979 by the Voyager spacecraft. Unlike Saturn's majestic rings, Jupiter's are dark and thin, made mostly of dust kicked up by tiny meteorites striking its small inner moons. They're subtle, delicate, and almost invisible, a ghostly halo around a planetary titan. But what truly sets Jupiter apart is its family of moons. As of now, scientists have confirmed at least 95 natural satellites orbiting Jupiter, with more still being discovered. These moons range from tiny, irregular space rocks to some of the most intriguing worlds in the solar system. 4 of these moons, the Galilean moons, were discovered by Galileo Galilei in 1610, and they remain some of the most fascinating objects ever observed. First, there's Io, the innermost of the 4, which is the most volcanically active body in the solar system. Its surface is dotted with hundreds of volcanoes that constantly spew sulfur and lava. The result? A landscape that looks like a pizza, if that pizza were trying to kill you. Next is Europa, a smooth, icy moon with very few craters. Beneath its frozen crust, scientists believe there's a vast salty ocean, possibly twice the volume of all Earth's oceans combined. And where there's liquid water, there may be life. Europa is one of the most promising places to search for alien microbes, and future missions are already in the works to probe its hidden sea. Then there's Ganymede, the largest moon in the solar system, even bigger than the planet Mercury. Ganymede has its own magnetic field, a rare trait for a moon, and likely harbours a subsurface ocean of its own. It's a world of icy crusts, ancient terrains, and quiet mysteries. Finally, we come to Callisto, a heavily cratered moon that has been geologically inactive for billions of years. It's like a cosmic scrapbook, preserving the record of ancient impacts that go back nearly to the dawn of the solar system. These moons are not just side characters, they are worlds in their own right, each with a unique story, each influenced by Jupiter's massive gravitational pull. In fact, Jupiter's gravity is so powerful that it helps shape the architecture of the entire solar system. It's thought to have deflected countless asteroids and comets, possibly even shielding Earth from more frequent impacts. It's a bit like a cosmic bouncer, keeping trouble away from the inner planets. And yet, despite all its might, Jupiter is also a planet of beauty. Its auroras, glowing curtains of light near the poles, are the brightest in the solar system. Created by charged particles spiralling along magnetic field lines, these auroras are 1,000 times more powerful than those on Earth. They flicker and dance in ultraviolet and infrared light, unseen by human eyes but dazzling through the lens of a space telescope. Humanity has long been fascinated by Jupiter. Ancient civilizations knew it as the king of the planets, bright, slow-moving and steady. The Romans named it after their chief god. The Babylonians tracked its movements with careful precision. Today, spacecraft like Juno continue to orbit Jupiter, peering beneath its clouds with instruments that sense magnetic fields, gravity waves, and deep atmospheric currents. And yet, for all we've learned, Jupiter remains in many ways unknowable. What lies at its centre? A rocky core or something stranger? How do its storms form and persist for centuries? What secrets are hidden in the hearts of its moons? These are questions that remind us just how young we still are in the grand age of exploration. So picture it now, a world larger than life, spinning fast, roaring with winds, cloaked in clouds, circled by moons, and glowing with ancient light. A world that humbles our ambitions and expands our curiosity. Jupiter doesn't offer easy answers, but it offers wonder, and in that quiet drift between stars, sometimes wonder is exactly what we need. Beyond the swirling might of Jupiter lies a planet of quiet elegance, Saturn. The 6th planet from the Sun, Saturn is best known for its breathtaking rings, so delicate and dazzling, that they've become an icon of the cosmos. If Jupiter is the king of the solar system, Saturn is surely the artist, graceful, adorned, and full of secrets that whisper from beneath its icy halos. Saturn is the second largest planet in the solar system, stretching over 72,000 miles across its equator. Like Jupiter, it's a gas giant, made primarily of hydrogen and helium. And just like its larger sibling, Saturn has no solid surface, at least none we could ever stand on. As you move down into its thick atmosphere, the gas would become denser and hotter until it transitioned into a liquid and, eventually, to something scientists call metallic hydrogen. It's not a surface in any traditional sense, more like falling into an ever-thickening fog that never quite becomes solid beneath your feet. Despite its enormous size, Saturn is surprisingly light. If you could find a bathtub big enough, and we admit that's a stretch, Saturn would float in water. It's the least dense of all the planets, with a bulk made of gases far lighter than the rock and metal that make up the inner planets. A giant weightless balloon, drifting in slow motion around the Sun. And then there are the rings. Saturn's rings are made mostly of ice, ranging from minuscule grains to house-sized chunks. They span over 270,000 miles from edge to edge, but are remarkably thin, sometimes only 30 feet thick in places. That's like spreading a sheet of paper across a football field. They're divided into several main groups, creatively named the A, B, C, D, E, F, and G rings, with gaps like the Cassini division separating them. When sunlight hits these icy particles, they shimmer like frozen lace in the blackness of space. Though they appear solid from Earth, Saturn's rings are more like a vast spinning cloud of icy debris, each fragment orbiting the planet like a miniature moon. The origin of the rings is still a topic of debate. They may be the remnants of a shattered moon, or perhaps leftover material from the planet's formation. Some scientists believe they're relatively young, maybe only 100 million years old, while others think they've been there for billions of years, constantly recycled by Saturn's gravity. But Saturn is far more than just its rings. It has an impressive family of moons, at least 145 confirmed so far, with more discovered almost every year. Some of these are tiny, irregular chunks of rock. Others are worlds in their own right, each with its own landscape and personality. One of the most remarkable of Saturn's moons is Titan, the second largest moon in the solar system, even bigger than the planet Mercury. Titan has a thick, hazy atmosphere made mostly of nitrogen, with a hint of methane. Its surface is bitterly cold, around minus 290 degrees Fahrenheit, and features rivers, lakes, and even seas, not of water, but of liquid methane and ethane. It's like Earth in a funhouse mirror, eerily familiar yet utterly alien. Titan is also one of the only bodies in the solar system with stable liquids on its surface, and one of the few places with weather, including rain, wind, and clouds. It even has dunes made of organic molecules and ice volcanoes that may erupt with slushy mixtures from beneath the surface. Scientists believe Titan might have an underground ocean of salty water as well, making it a tantalizing candidate in the search for extraterrestrial life. Another of Saturn's moons, Enceladus, is smaller but no less fascinating. It's an icy sphere only a few hundred miles across, but it has captured imaginations with its geysers, jets of water vapour and ice particles that shoot out from cracks near the South Pole. These plumes suggest the presence of a subsurface ocean beneath the ice crust. The Cassini spacecraft, which orbited Saturn from 2004 to 2017, flew through these geysers and detected organic compounds, salts, and water, all ingredients that hint at the possibility of life below. Cassini revealed countless wonders about Saturn during its 13-year mission. It studied the planet's magnetic field, its complex atmosphere, its seasonal changes, and its majestic rings. It took close-up photographs of moons, dived between the rings, and ultimately ended its journey with a dramatic plunge into Saturn's atmosphere, where it burned up like a falling star to avoid contaminating the very moons it had studied. It was a fitting end for one of humanity's most ambitious planetary explorers. Back on the planet itself, Saturn's atmosphere is no less interesting. It has banded cloud layers like Jupiter, but they're subtler, more subdued, like stripes painted in soft pastel tones. Occasionally, Saturn erupts in massive storms that can circle the entire planet. One particularly famous storm, observed in 2010, raged for months and created a massive spiralling vortex in the northern hemisphere. And near Saturn's north pole lies a geometric oddity, a six-sided jet stream shaped like a perfect hexagon. This mysterious atmospheric feature has puzzled scientists since it was first discovered, spinning calmly like a great planetary snowflake. Saturn also rotates quickly, completing one spin in just over 10 hours. Its rapid rotation contributes to its flattened shape, more oblate than any other planet. The equator bulges, the poles flatten, and the entire planet looks just a bit squished, like a spinning balloon caught mid-twirl. From Earth, Saturn is a jewel in the night sky, golden, distant, and beautiful. Even a small telescope reveals its rings, creating gasps of wonder for anyone seeing them for the first time. For centuries, Saturn has inspired awe, poetry, and myth. To the ancient Romans, it was named after the god of time and harvest, a slow-moving planet that drifts through the sky with stately grace. But for all its grandeur, Saturn remains a place of silence. There are no cities, no songs, no footsteps echoing in its clouds. Only ice, gas, gravity, and the long, slow dance of moons that circle it in endless orbits. So as you lie in bed, let yourself float in the silence of Saturn. Imagine the soft glow of its rings, the frozen air of Titan, and the icy plumes of Enceladus reaching for the stars. This is a planet that reminds us of beauty, mystery, and the quiet dignity of distant things. Rest easy now. The ringed planet keeps turning, a silent sentinel in the outer dark, waiting for the next explorer to come and listen. As we continue our gentle drift outward from the sun, we arrive at a planet that seems to have taken the rulebook, tossed it over its shoulder, and spun off sideways into the cold. Welcome to Uranus, the seventh planet from the Sun, and perhaps the most quietly rebellious world in the solar system. Uranus is a gas giant like Jupiter and Saturn, but it's more precisely classified as an ice giant due to the higher concentrations of substances like water, ammonia, and methane in its atmosphere. It's enormous, about 4 times wider than Earth, yet it hides its strangeness beneath a calm pale blue facade. From a distance it looks peaceful, almost soothing, but there's much more going on beneath that tranquil hue. The first thing to know about Uranus is that it's tilted dramatically. Most planets spin with their poles roughly up and down relative to their orbit, like spinning tops wobbling slightly. But Uranus rolls around the Sun on its side. Its axial tilt is about 98 degrees, meaning that its north and south poles lie where most planets have their equators. In other words, it doesn't just rotate, it lounges. This extreme tilt leads to some truly bizarre seasons. Each pole gets around 42 Earth years of continuous sunlight, followed by 42 years of darkness. Imagine living in a place where summer lasts 4 decades, and then, without warning, winter descends and stays for the next 4. Weather patterns on Uranus are still not fully understood, but its sideways spin certainly contributes to a unique and deeply alien climate. A day on Uranus lasts about 17 Earth hours, meaning it rotates fairly quickly, especially considering its tilted orientation. But despite that rapid spin, the atmosphere appears oddly featureless most of the time. Unlike Jupiter's colourful storms or Saturn's swirling bands, Uranus often looks smoothed and unchanging. This led some scientists to nickname it the Bland Giant, which, frankly, seems a bit rude for a planet with such personality. However, that calm appearance is deceptive. When viewed in infrared light or during seasonal changes, storms and cloud bands become visible, revealing a much more dynamic world beneath the soft exterior. Winds can reach speeds of over 500 miles per hour, and the planet's atmosphere contains thick layers of icy clouds, including water, ammonia, and methane. Methane is especially important here. It absorbs red light and reflects blue and green, which gives Uranus its distinctive pale blue colour, a hue that, from afar, feels almost serene. But beneath that serene surface is a world of immense pressure, freezing temperatures, and strange chemistry. Temperatures on Uranus are some of the coldest in the solar system. The average temperature is around minus 350 degrees Fahrenheit. That's colder than any other planet, even though Neptune, farther from the Sun, is slightly warmer. Scientists believe this might be because Uranus gives off very little internal heat. While Jupiter and Saturn radiate much more energy than they receive from the Sun, Uranus barely emits any at all. Why? That remains one of the planet's many mysteries. Uranus also has a magnetic field, but, like everything else about it, it's a little off-kilter. Unlike Earth's magnetic field, which is fairly aligned with its rotation, Uranus's magnetic field is tilted by about 60 degrees from its axis and is offset from the planet's centre. It's as if the entire magnetic field is wobbling awkwardly, dancing to its own rhythm. Now, let's talk about rings. Yes, Uranus has rings, although they are far less famous than Saturn's. They're dark, narrow and faint, made mostly of large icy particles with some mysterious dark material coating them. There are 13 known rings and more may yet be discovered. The rings were first detected in 1977 when Uranus passed in front of a distant star and briefly blocked its light, not once but several times due to the ring's presence. And of course there are moons, at least 27 of them. Unlike the mythological names used for most planets and their moons, Uranus's moons are named after characters from the works of William Shakespeare and Alexander Pope. There's Miranda, Ariel, Umbriel, Titania and Oberon, all tumbling in strange inclined orbits around their tilted parent. Miranda, one of the innermost moons, is especially fascinating. It's a small icy world with enormous cliffs, deep canyons and twisted terrain. Some of these cliffs are among the tallest in the solar system, towering walls of rock and ice that plunge 12 miles downward. Miranda looks like it's been shattered and stitched back together, with terrain so strange it once led scientists to joke that the moon must have been assembled on a Friday. Then there's Ariel, the brightest of Uranus's moons, with canyons carved by ancient geological activity. Titania and Oberon are larger and darker, dotted with impact craters and mysterious ridges. These moons are worlds in their own right, shaped by ancient forces we are only beginning to understand. Only one spacecraft has ever visited Uranus, NASA's Voyager 2, which flew past in 1986. During its brief encounter, Voyager revealed Uranus's rings, its tilted magnetic field and its peculiar moons. But no mission has returned since. Most of what we know comes from telescopes and computer models, and there's still so much we don't know. Plans are slowly forming for future missions, and scientists hope to one day send an orbiter to explore Uranus in detail, to answer lingering questions and uncover new ones. Uranus doesn't often get the spotlight. It orbits slowly, silently, about 1.8 billion miles from the Sun, completing one orbit every 84 Earth years. It's dim, distant and sometimes overlooked, but it has a quiet charm all its own, a tilted wanderer softly glowing in blue, with rings that whisper and moons that remember. It reminds us that even the quietest planets can be strange, and even the strangest planets can be beautiful. Uranus is a cosmic oddball, spinning sideways through the dark, content to be different, content to move at its own pace. So as you close your eyes and drift into sleep, imagine that gentle blue world turning slowly in the cold. Let the thought of tilted moons and icy clouds carry you across the distance. Somewhere, far beyond the reach of sunlight, Uranus rolls on, sideways, silent, serene, a dream in blue waiting to be explored. As we venture even farther from the warmth of the Sun, we arrive at Neptune, the eighth and final planet in the solar system. Cold, distant, and strikingly beautiful, Neptune is a world of wind, ice, and deep blue mystery. It orbits nearly 3 billion miles from the Sun, a realm so far away that sunlight takes over 4 hours to reach it. By the time the light arrives, it's barely a whisper, a soft glow in a world of frost and silence. Neptune is another ice giant, like Uranus, made primarily of hydrogen, helium, and various ices, including water, methane, and ammonia. It's slightly smaller than Uranus in size, but more massive, which makes it the densest of the giant planets. If Uranus is the quiet, sideways spinner, Neptune is its darker, stormier sibling, a planet with power hidden beneath a calm blue face. That distinctive blue hue comes from methane in the atmosphere, which absorbs red light and reflects blue. But there's something more to it. Neptune is an even deeper, more vivid blue than Uranus, and scientists are still trying to understand exactly why. It may be due to differences in atmospheric composition or the size of haze particles, but whatever the cause, the result is stunning. A rich sapphire world glowing gently in the dark. One of Neptune's most striking characteristics is its weather. For such a cold planet with average temperatures near minus 375 degrees Fahrenheit, it's surprisingly stormy. In fact, Neptune has the fastest winds of any planet in the solar system. Some of its jet streams reach speeds of over 1,200 miles per hour. That's faster than the speed of sound, so booming. A fact that feels especially surreal when you consider the atmosphere is so cold and thin. In the late 1980s, NASA's Voyager 2 spacecraft flew past Neptune and captured images of a massive dark storm system. Dubbed the Great Dark Spot. It was roughly the size of Earth and spun counterclockwise in the southern hemisphere. Unlike Jupiter's Great Red Spot, which has lasted for centuries, Neptune's dark spots seem to appear and disappear over the course of just a few years. They are vast whirlpools of high-pressure systems wrapped in bands of white methane clouds that swirl like whipped cream on an invisible storm. Voyager 2 also discovered smaller storms, like the Scooter, a fast-moving cloud zipping around the planet, and bright, high-altitude methane clouds that cast shadows on the layers below. All of this activity makes Neptune feel alive, even though it is so distant, so cold, and so removed from the busy inner solar system. Neptune's rotation period is roughly 16 hours, a short day for such a large planet. Like the other gas and ice giants, Neptune bulges slightly at the equator due to its rapid spin. Beneath the atmosphere, scientists believe Neptune has a slushy interior of water, ammonia, and methane ices surrounding a rocky core. It's not a place you could ever stand or even float, just layer after layer of increasingly dense and hostile materials. But Neptune isn't alone out there. It has a system of faint rings and a collection of at least 14 known moons, each one unique in its own way. The rings are dark, dusty, and far less pronounced than Saturn's, but they're still remarkable. Some of the rings are clumpy, with curious arcs that scientists believe may be shaped by the gravitational influence of nearby moons. The largest and most famous of Neptune's moons is Triton, a truly bizarre and captivating world. Triton is the only large moon in the solar system that orbits its planet in the opposite direction of the planet's rotation, a movement known as a retrograde orbit. This suggests that Triton didn't form alongside Neptune but was likely a captured object, perhaps a Kuiper belt body that strayed too close and was pulled into orbit long ago. Triton is also geologically active. When Voyager 2 flew past, it observed geysers erupting from the surface, plumes of nitrogen gas and icy particles shooting miles into the thin atmosphere. The surface itself is a strange frozen mix of plains, ridges, and cantaloupe-textured terrain, sculpted by unknown forces. Triton may even have a subsurface ocean, kept warm by internal heat despite the freezing temperatures at the surface. Because of its retrograde orbit, Triton is slowly spiraling inward toward Neptune. Eventually, billions of years from now, It may either crash into the planet or be torn apart, forming a temporary ring system. It's a slow-motion celestial ballet playing out over epochs. Neptune, like Uranus, has only ever been visited by one spacecraft, Voyager 2. That brief flyby in 1989 gave us most of what we know about the planet, and the encounter lasted just a few days. Since then, Neptune has been observed through powerful telescopes, but many of its secrets remain untouched. It is in many ways the most mysterious of the major planets, a giant whose story is still largely unread. Despite its distance, Neptune holds a special place in astronomical history. It was the first planet discovered not by direct observation, but by mathematics. In the early 1800s, astronomers noticed that Uranus's orbit wasn't behaving as predicted. Something seemed to be tugging on it, something invisible. French mathematician Urbain Le Verrier and English mathematician John Couch Adams independently calculated where this unseen planet should be. And when astronomers pointed their telescopes to that spot in 1846, there it was. Neptune, shimmering quietly at the edge of our solar system. A triumph of intellect and curiosity, and perhaps that's Neptune's legacy, a reminder of how much can be discovered through patience, collaboration, and imagination. We've barely scratched the surface of this icy giant. Future missions may someday orbit Neptune, explore its moons, and dive into its atmosphere. Until then, it remains a cold blue beacon in the outer dark, a promise of adventure still to come. So as your eyes grow heavy, picture that distant world spinning silently, its winds rushing faster than sound, its clouds swirling above hidden storms. Imagine standing on the frozen plains of Triton, watching the faint sun rise slowly over the horizon, a pale dot in an endless sky. Neptune is the last of the major planets, a sentinel at the edge of sunlight's reach. It whispers of unseen places, of secrets not yet told, and tonight it keeps spinning, quiet, cold and beautiful, far beyond the warmth of day, beneath a sky of distant stars. And so, we've reached the end of our quiet journey through the solar system. 8 unique worlds, each one orbiting the same warm star, yet each shaped by different forces, temperatures, and timescales. From Mercury's scorched and cratered surface to Neptune's icy blue tempests, every planet tells its own story, carved in rock, gas, and silence. These are not just distant objects floating in the void, they're reminders of what is possible in the universe. Some are familiar, like Earth with its oceans and forests and soft, breathable skies. Others, like Uranus and Neptune, feel utterly alien, spinning, storming, and glowing far from our reach. Yet they are all part of the same family, held in balance by gravity, moving to the slow rhythm of orbits that stretch over days, decades, and centuries. And you, listening here tonight, are part of that system too. You're made from the same elements as the stars, planets, and moons. You breathe the oxygen Earth gives, warmed by sunlight that began its journey across space over 8 minutes ago. You sleep under the same stars that have watched over these planets for billions of years. Perhaps you found this journey relaxing. Perhaps it even made you a little sleepy. And if it did, well, I've done my job. But if it was too interesting to sleep through, I hope you learned something new, something gentle and curious to carry with you into your dreams. After all, the best kind of rest is the kind that starts with a spark of wonder. If you're still awake, I'd love to know, where in the world are you listening from? And what time is it for you right now? Are you tucked in for the night, just drifting off? Or perhaps listening during a quiet afternoon, letting your mind wander among the stars? And if you've enjoyed this journey, this quiet orbit through our cosmic neighborhood, it would mean so much if you could tap the like button or even subscribe to The Sleepy Scientist. There are many more gentle adventures to come, and I'd love for you to be a part of them. But for now, close your eyes if you haven't already. Breathe in, let the planets drift away behind you like dream tales fading with the dawn. The solar system keeps spinning and you are safe within it, calm, small and perfectly placed among the stars. Sleep well, traveller, until next time.